Pre-AP Calculus, looking at notes 9.2, we are introducing circular trigonometry, trying to get us to the unit circle. I believe we're going to have 4 videos in this section, and this first one is just hitting terminology super hard. An angle. An angle is defined as a figure formed by 2 rays that have the same endpoint. So that's a picture of an angle. Initial side of an angle and the terminal side of an angle. Initial side of an angle is a ray and an angle that remains fixed. So let's say that I have this ray here, and let's say it doesn't move. And let's say that I have this ray here, and it is moving. It's moving until I stop it. So let's say I stop it right here. The red ray is called the initial side. The blue ray is called the terminal side. Now, when you look at the static picture, how do we know which one moved? I mean, you saw me moving it, but once the picture is drawn, how could you tell? Well, generally, we draw an arc with an arrow on it that denotes movement. That's denoting that we started here on the x-axis, and then our angle rotated up here, the terminal side, to form the angle. Another example, let's say that our initial side is the positive x-axis again. Let's say we rotate in the clockwise direction, like so. This is the initial side. This is the terminal side. So 2 important terms. We're going to use those terms in other terms. Positive angle and a negative angle. A positive angle is an angle formed by the terminal side rotating counterclockwise. So let's say that our initial side, I don't want to say abbreviate it like that, that's silly. Well, I'll tell you what, let's not label it initial. Let's just use the arrow like I was saying. Let's say that we have this angle here, and we got it by rotating counterclockwise. That is a positive 45 degrees. Let's say that we have that same angle, but it was formed by rotating in this direction clockwise. That would be 315 degrees negative, because we went in the negative direction. So if you go counterclockwise, it's positive. If you go clockwise, it's negative angle. I'm sure that you've wondered often, why do we name the quadrants as ridiculous as we do? And it's because we're going to be defining the positive x-axis as 0 degrees. And as we go around this counterclockwise, we're going up to 90, 180, 270, 360, in the order in which the quadrants are named. So the quadrants are named the way they are because of this positive angle system of being counterclockwise. Standard position and quadrantal angle. An angle with its vertex at the origin, so vertex here, and its initial side on the positive x-axis, like so, that is an angle in standard position. Now the terminal side can be any place. Let's say this is the terminal side. And let's just assume that we went in this direction, although we could have also went in this direction, it wouldn't make a difference. This is called standard position. A quadrantal angle. An angle in standard position, so we know right away the vertex is here and the initial side's on the positive x-axis, whose terminal side coincides with one of the axes. So the terminal side could be same place the initial side is, could be on the positive y-axis, negative x-axis, negative y-axis. All of those are quadrantal angles. It means the terminal side ends up on an axis and it's in standard position. Coterminal angles. Two angles in standard position whose terminal side coincide with each other. Let's say that we drew the quadrantal angle of 90 degrees in standard position. An angle that's coterminal with this, work with me here, we could start here at 0 and we could go all the way around to 360 degrees and go 90 more to 450 degrees. That's coterminal with 90. We could go another revolution. That would be 360 more. That would be 810 degrees. We could also go in the negative direction, negative 270 degrees. Long story short, I'm saying that 90 and negative 270 degrees are coterminal. We have the same terminal side. Another example, let's say that we have an angle here that is 225 degrees. Once again, this is 90, 180, 270, 360, also 0. We could also go, I'm going to make a complete revolution, come around and end up here again. That would be 225 plus 360 more, so that would be 585 degrees. So 225 and 585 degrees are coterminal. What's the relationship between coterminal angles aside from the definition? Coterminal angles are complete revolutions apart, and it can be multiple complete revolutions apart. So coterminal angle, say coterminal to alpha, would be alpha plus 360 n, 360 degrees n, where n is an integer. So you can go in the positive direction or negative direction as many revolutions as you want, and those are going to be coterminal. Degrees, minutes, and seconds. An angle has a measure of 1 degree if it results in 103/60th of a complete revolution in the positive direction. Here's what that means. 1 revolution equals 360 degrees. That's what you need to know. Minute. Each minute is comprised of 60 of these. This is the symbol for minute. So that means what we're saying is 1 degree is equivalent to 60 minutes. Seconds. Each minute is comprised of 60 of these. So 1 minute is equivalent to 60 seconds. Almost done with the introduction here with all these terms. It says draw a circle with a radius 1 whose center is at the origin. Label each angle around the circle counting by 30 degrees and 45 degrees. All right, well, let's do that. This is a skill that you should be able to do. Without a calculator. First of all, the radius is 1. That means that the distance from the center of the circle to the circle is 1. These are all 1. If we count by, let's do the 45 degrees first. Well, let's just label the quadrantal angles first. We got 0 degrees, 90 degrees, 180, 270, and then 360. If we count by 45, 45 is halfway between 0 and 90. So we got 0 times 45, 1 times 45, 2 times 45, 3 times 45, 4 times 45, 5 times 45, 6 times 45, 7 times 45, and then 8 times 45. Just adding 45 each time. We have to also count, it says, by 30s. So between 0 and 90, there are 3 equal things of 30. 30, and then 60, and then 90. And then 30 more than 90 is 120. 30 more than 120 is 150. And then 30 is 280, and then 210, and then 240, and then 270, and then 300, and then 330. Takes us back to the beginning of 360. Now that's too much to put in one picture, and you could have drawn 2 pictures, one counting by 30 degrees and one counting by 45. I just put them all in the same picture. If it's too much, draw 2 separate triangles, one with the black stuff and one with the blue stuff, but also include the circle and the quadrantal angles. That is an introduction to the terminology of this section. I'm going to have 3 more videos, I believe, for this section.